Yes, Legendre polynomials. Legendre polynomials. First of all, Legendre differential equation ante enti telusukundam. Definition: Legendre differential equation. The differential equation, the differential equation of the form 1 minus x square into d square y by dx square minus 2x times dy by dx plus n into n plus 1 into y equals to 0. So a differential equation in the form of 1 minus x square into d square y by dx square minus 2x times dy by dx plus n into n plus 1 into y equals to 0 is called Legender's differential equation. Legendre differential equation, or it may be called as Legender's equation, where n is constant, Okay, so an equation in the form of 1 minus x square into d square by dx square minus 2x dy by dx plus n into n plus 1 into y is equal to 0 is called as Legendre equation. So, and the solutions of Legendre equations are, solutions. Just remind it, just solutions are y is equals to a naught times x power n minus n into n plus 1 into x to the power of n minus 2 by 2 times 2n minus 1 plus n into n minus 1 into n minus 2 into n minus 3 by 2 into 4 into 2n minus 1 into 2n minus 3 into x to the power of n minus 4 plus and so on, or y is equals to a naught times x power minus n minus 1 plus n plus 1 into n plus 2 by 2 into 2n plus 3 into x to the power of minus n minus 2 plus n plus 1 into n plus 2 into n plus 3 into n plus 4 whole by 2 into 4 into 2n plus 3 into 2n plus 5 into x to the power of minus n minus 4 and so on. These are the solutions for the Legender's equation. 1 minus x. We get these solutions by taking power series solutions. So by supposing y is equals to sigma x to the power of n into sigma an into x to the power of n running from 0 to infinity, we get these two solutions. So these solutions are the Legender's functions. So y is equals these solutions are the Legender's functions or Legender's polynomials. So these solutions are the Legender's functions or Legender's polynomial. So the what is the Legender's function of the first kind? So we get two solutions. So first one is first kind solution and second was second kind solutions. So first of all, Legender's Legender's function of of first kind, Legender function of first kind. If n is a positive integer, if n is a positive integer, and a naught is equals to 1 into 3 into 5 into and so on 2n minus 1 by n factorial, and a naught is equals to 1 into 3 into 5, then the solution y is equals to a naught, then the solution a naught into x to the power of n minus n into n plus 1 by 2 into 2n plus 1 into x to the power of n minus 2 and so on of Legender's equation Legender's equation is denoted by Pn of x, is denoted by Pn of x, and is called as Legender's function, of first kind. So we get two solutions. The first solution is called as Legender function of the first kind. Now Pn of x can be written as, so now now this implies that Pn of x is equals to in place of a naught, put that thing p naught is equals to Pn of x is equal to 1 into 3 up to 2n minus 1 by n factorial into yes, Pn of x is equals to a naught value, what is the value of a naught? 1 into 3 into 5 into up to 2n minus 1 by n factorial into x to the power of n minus n into n plus 1 by 2 into 2n plus 1 times x to the power of n minus 2 and so on. That is Pn of x is equals to, Pn of x is equals to sigma. Therefore Pn of x can be written as sigma minus 1 to the power of r running from 0 to n by 2, 2n minus 2r factorial by 2 to the power of n into r factorial into n minus 2r factorial into n minus r factorial into x to the power of n minus 2r. So Pn of x is equals to sigma r running from 0 to n by 2 minus 1 to the power of r 2n minus 2r factorial by 2 to the power of n into r factorial into n minus 2r factorial into n minus r factorial into x to the power of n minus, where n by 2 is where n by 2 is n by 2, where n by 2 is equals to n by 2 when n is even, and n by 2 value should be considered as n minus 1 by 2 when n is odd, Hmm? Once again, Legendre function of the first kind, where a naught is equals to 1 into 3 into 5 into so and so forth up to 2n minus 1 by n factorial. Then the solution y is equals to a naught into x to the power of n minus n into n plus 1 by 2 into 2n plus 1 into x to the power of n minus 2 and so on. This is called as the Legendre equation, and it is denoted by Pn of x, and is called as Legendre function of first kind. Therefore Pn of x can be written as substitute the value of a naught as 1 into 3 into 5 into and so on 2n minus 1 by n factorial. Then Pn of x can be written as 1 into 3 into 5 and so on 2n minus 1 by n factorial into x to the power of n minus n into n plus 1 by 2 into 2n plus 1 into x to the power of n minus 2 and so on. So finally you need to remember only this thing, this particular thing is that Pn of x value is sigma minus 1 to the power of r into 2n minus 2r factorial by 2 power n into r factorial into n minus 2r factorial into n minus r factorial into x to the power of n minus. The n value of n by 2 is remains same when n is even, but the value of n by 2 value is n minus 1 by 2 when n is odd. This is the main thing you need to remember. Next, second kind. Now second kind. So the second kind, just remind it, the second kind Legender's function, function denoted with Qn of x. Okay, first kind denoted with Pn of x, and the second kind denoted with Qn of x, and the value of Qn of x and the value of Qn of x it is also solution for the Legender's polynomial. Qn of x value is n factorial by 1 into 3 into so and so forth 2n plus 1 into x to the power of minus n minus 1 plus n into n plus 1 into n plus 2 by 2 into 2n plus 3 into x to the power of minus n minus 2 plus and so on. Here he never detailed give in this throughout the chapter he never given detailed explanation about second kind. It means that most of study in this chapter, most of study on first kind only. So you need to remember this value only. The Pn of x is, reminder, the Pn of x is summation of minus 1 to the power of r into 2n minus 2r factorial by whole divided by 2 power n into r factorial into n minus 2r factorial into n minus r factorial into x to the power of n minus 2r factorial. So the summation, in the summation value, the upper bound value should be remain n by 2 when n is even. The upper bound value is n minus 1 by 2 when n is odd. So when if there is a question on second kind, just write this. What is the Legender's differential equation? The Legendre differential equation, which is in the form of 1 minus x square into d square y by dx square minus 2x into dy by dx plus n into n plus 1 into y equals to 0, where n is constant. This is the Legender's differential equation, and Pn of x and Qn of x are solutions for the Legender's differential equation. Pn of x is called as Legender's first kind function, Legendre function of the first kind, and the Qn of x is called as Legendre function of second kind. So there is no particular summation notation for the second kind. So the first kind, so the general solution, and note that the general solution of the Legender's equations, of the Legender's equation or Legender's differential equation is y is equals to a times Pn of x plus b times Qn of x. where Pn of x is the summation notation, where A and B are arbitrary constants, where A and B are arbitrary constants. Okay. And what is the generating function? Right? Next definition, generating function. Generating function. The value 1 minus 2xx minus plus h square to the power of minus 1 by 2. 1 minus 2xh plus h square to the power of minus 1 by 2 is called the generating function, of the Legender's polynomial. Generating function of the Legender's polynomial. So just by heart the value of Pn of x. Pn of x is equal to sigma r running from 0 to infinity to Pn of x is equal to sigma r running from 0 to n by 2 minus 1 to the power of r and 2n minus 2r factorial by 2 to the power of n into r factorial into n minus 2r factorial into n minus r factorial into x to the power of n minus 2r, where when n is even, r running from 0 to n by 2, when n is odd, r running from 0 to n minus 1 by 2. Okay. Now we try to find the values of the polynomials p naught x, like the previous Hermite one, like Chebyshev polynomial. How to find the functions of in Chebyshev polynomial, how to find the functions in Hermite polynomial. Here also we find the polynomial values when n is equal to 0, when n is equal to 1, when n is equal to 2, and so on. So the values problems. Show that okay, p naught of x is equals to 1. Show that p naught of x is equal to 1, first problem, and p1 of x is equals to x, second problem, and p2 of x is equals to 1 by 2 times 3x square minus 1 by 2 into 3x square, and p3 of x is equals to 1 by 2 into 5x cube minus 3x, and p4 of x is equals to 1 by 8 into 35 x to the power of 4 minus 30 x square plus 3. We will do this problem. First one, what is the value of p naught of x? Okay. Generating function. We multiply with generating function. So the value of generating function by the definition of generating function. Just remind this value, summation solution I'm writing solution, since sigma h power n, into Pn of x, n running from 0 to infinity, this value is equals to 1 minus 2xh plus h square to the power of minus 1 by 2. I already write this. It is called a generating function. When we multiplying the Pn of x with h square, we will get this generating function 1 minus 2hx plus h square to the power of minus 1 by 2. So by using that value, the value of sigma h to the power of n Pn of x can be written as like this. So this can be written as 1 minus h is common minus 2x minus h 2x minus h to the power of minus 1 by 2. Okay, now I expanding this using the value 1 minus x to the power of minus n. 1 minus x to the power of minus n is equal to 1 plus nx plus, right? By using that formula I expanding this 1 plus 1 by 2 into nx 1 plus nx 1 plus nx, n is 1 by 2 and x is h times 2x minus h 1 plus nx plus nc2. Next, nc2 means 1 into 3 1 into 3 by 2 into 4 into h square into 2x minus h whole square. Okay, next plus 1 into 3 into 5 by 2 into 4 into 6 into h cube into 2x minus h whole cube and so on. This is the general expansion by using the formula 1 minus x to the power of minus n. 1 minus x to the power of minus n, basic formula 1 minus x to the power of minus n formula. So 1 minus x to the power of minus n, so this can be written as, so this is equals to p naught of x plus h into p1 of x plus h square into p2 of x plus h cube into p3 of x plus h to the power of 4 into p4 of x and so on and so on. So this is this expansion gives p naught of x. So comparing the constant values and h coefficients, we will get the values. So this can be written as, so I once again writing this. So here only one constant, it is 1. So second term should be written in form of x coefficient of x. What is the coefficient of x in the second term? In the second term, the coefficient of x is equal to x into h. The second coefficient x plus h, and after that h square coefficient is here we get minus h square by 2, here we get minus h square by 2, and here we get 2x times 1 into 3 into 2 into 4. So common h square is common, so it can be written as 1 by 2 into 3x square minus 1 into h square and plus 1 by 2 into 5x cube minus 3x into h cube plus 1 by 8 times 35 x to the power of 4 minus 30x square plus 3 into h to the power of 4 and so on. So comparing the coefficients of h, we get comparing the coefficients on both sides, we get the value of p naught of x. The value of p naught x is 1. The value p1 of x is the coefficient of h is x, and the p2 of x is equals to the coefficient of h square is equals to 1 by 2 into 5x cube minus 3x, and the p3 of x is equals to coefficient of x cube is x1 and x, and after that 1 by 2 into, this value is p3 of x is equals to 1 by 2 into 3x square minus 1. This is coefficient of h square, and p3 of x is equal to coefficient of h cube is 1 by 2 into 5x cube minus 3x, and p4 of x is equals to coefficient of h to the power of 4. That value is equals to 1 by 8 times 35 x to the power of 4 minus 30 x square plus 3 plus 3 plus 3. So this is the value of p4x. This is the process for finding the p0, p1, p2 and so on and so forth. And next problem. Prove that for all x, first one, x square is equals to 1/3 p0 of x plus 2/3 p2 of x. Okay. And second one, x cube is equals to 3/5 into p1 of x and 2/5 into p2 of x. Okay. So right. So we already find the values of p0 of x and p0. We know the values p0 of x and p1 of x. So consider the RHS value. Consider the RHS and get the LHS value. First one, what is the RHS value? First one, RHS is equals to, what is the value of RHS? RHS is equals to 1/3 p0 of x, 1/3 p0 of x plus and 2/3 p2 of x, 2/3 p2 of x, 2/3 p2 of x. Okay, 2/3 p2 of x. So this is equals to 1/3 p1 of x is p0 is 1. Okay, p0 of x is equals to 1. So 1/3 into 1 plus 2/3 into p2 of x. What is the value p2 of? p2 of x is equals to half of 3x square minus 1. Half of 3x square minus 1. Okay, this is equals to 1/3 plus 2 get cancel, 2 get cancel. 3/3 is x square minus 1/3. So plus 1/3 minus 1/3 is 0. It is equals to x square, which is equals to the, it is the LHS value. Like that, the second RHS value. What is the second RHS value? Second RHS value is 3/5 of p1 of x, 3/5 of p1 of x plus 2/5 of p2 of x, 2/5 of p2 of x. Okay, so this equals to 3/5 of p1 of x is equals to, p1 of x is x, p1 of x is equals to x, and 2/5 of p2 of x is equals to, p2 of x is equals to half of 3x square minus 1, 3x square minus 1. So this is equals to 3/5 into x. Okay, 2 get cancelled, 2 get cancelled. So 1/3/5 plus 3/5 of x square, 3/5 of x square minus 1/5. So overall 3/5 is common. So what is x cube? We need to show that this value is x cube. X cube. 3x p2 of x is equals to 3x square. P2 of x is equals to 3x square, and x square value is 3/5 of x square. So here it is not p2, it is p3. Okay, again it is p3. So so it is p3. Okay, 2/5 of p3 of x. What is the p3 of x? p3 of x is equals to half of 5x cube minus 3x. So half of 5x cube minus 3x. Right. So this is equals to 3x by 5. Okay, 2 get cancel, 5 cancel, plus x cube minus 3/5 of x, 3/5 of x. 3x by 5 minus 3x by 5 is 0 plus x square, sorry, plus x cube is x cube, x cube is equals to the LHS. So in these cases, take the RHS value and prove the LHS value. Okay. It's all for this day. Bye.